Hello everyone, we are Group 9. The title of our design project is The Production of Acrylic Acid Plant from Propylene. The advisor of our group is Dr. Waritha Jantaporn. The outline of our presentation includes the introduction, process flow diagram and material balance, process description, development of plants, utility requirements, equipment costs, and economic analysis. Acrylic acid is an organic compound, which is an important raw material of polymer for many industrials and consumer products. It is the simplest unsaturated carboxylic acid, consisting of a vinyl group connected directly to a carboxylic acid, and acts as a colorless liquid with pungent smell at standard temperature and pressure. Acrylic acid is used in a variety of consumer and industrial goods. There are two commercially available grades of acrylic acid, which are technical grade and glacial grade. Technical acrylic acid is an approximately 94% purity by mass and is synthesized to acrylic esters. The esters are converted to comonomers, which are used to make surface coating, adhesive, sealants, textiles, and paints. Glacial or industrial acrylic acid is generally 99.5 to 99.9 purity by mass and is polymerized to produce polyacrylic acid-based polymers. These polymers are used to make detergents, dispersants, superabsorbent polymers such as diapers, and thickeners. In this project, we are going to produce glacial-grade acrylic acid with purity of 99.6% because of its high purity and high selling price. There are many existing processes for acrylic acid production such as acrylic acid by sequential dehydration and oxidation of glycerol, acrylic acid from ethylene, acrylic acid from propylene oxidation, acrylic acid from lactic acid, but the most common way which gives a high yield currently is the partial oxidation of propylene. In our process, we analyze the industrial scale production of propylene to acrylic acid. The usual mechanism utilizes a two-step process in which propylene is first oxidized to acrolein and then further oxidized to acrylic acid, where acrolein is a fast-acting intermediate. The main reaction and typical side reaction are shown here.
To produce acrylic acid from propylene, normally use two oxidation reactions in two reactors. The first reactor is the oxidation of propylene to acrolein as an intermediate, and the second reactor is the oxidation of acrolein to acrylic acid. But in our process, we use a single reactor model to analyze the response of both reactors. In our project, we decided to get the production rate of 60,000 tons per year. The location we select is Rayong Industrial Estate, Ban Khai, because this place is near to the raw material, other industry, and seaport. Only 80 kilometers from Lam Chabang Deep Sea Port, and only 50 kilometers from Maptaput Industrial.
The process flow diagram of acrylic acid production from propylene is shown on the screen. First, propylene, steam, and compressed air are mixed and fed to the reactor, which the operating temperature is 260 Celsius, then cool down and go to the fetch dam. Fetch dam separate of gas out. The liquid is then fed to the liquid extractor. In order to separate the water from acrylic acid, the liquid extractor is required because the boiling point of water and acrylic acid is too close. Boiling point of water is 100 Celsius, while boiling point of acrylic acid is 141 Celsius. The top stream leaving the extraction is entering to distillation column. In the top product from the distillation column, to avoid large solvent feed cost, the isopropyl ether is recycled back into the process. Is sent to the liquid extractor. Finally, the bottom product containing mostly acrylic acid and acetic acid is sent to an acid purification column. In the top product from acid purification column is dilute acetic acid and treated as waste. The bottom product is high concentrate acrylic acid which is then cold and sent to the storage.
Next topic is development of plant. First of all, the amounts of raw materials, propylene and oxygen are considered. The amount of propylene is calculated by conversion of the propylene to acrylic acid and run the simulation. On the other hand, the oxygen in the process is come from air. The effect of air feed flow rate to amount of the acrylic acid production out from the reactor is studied by sensitivity on the aspen class as shown in the figure. The use of 860 kmol per hour of air provides the desired acrylic acid production. At the lower amount of air, the compressor's electricity will be lower. Moreover, the amount of extract solvent is considered. The isopropyl ether of 27 kmol per hour was selected because it is the lowest amount of the solvent that provides the highest efficiency of water removal in liquid-liquid extractor. The ratio of spitter to steam number 28 is considered to find the proper value of recycled solvent steam back into the liquid-liquid extractor, which is 0.9. At higher recycled steam, the fresh feed solvent is lower. The lowest amount of raw material will save the cost of the raw materials. Moreover, two compressors with one intercooler should be used instead of one compressor because the temperature rise of air will be higher, and at the higher temperature, the efficiency of compressing of gas is lower. After the calculation of pinch analysis from problem table algorithm, two pairs of hot and cold steams are matched to minimize the utility cost.
Next topic is utility requirement. There are 6 types of utility used in the plant: low pressure stream, cooling water, electricity, refrigerant, hot oil, and waste disposal. The cost of utility expenses and the charge of each utility cost and the percentage of each utility cost are shown in graph. The highest utility cost of the process is cooling water, which is 50% of total utility cost. So the total utility cost of the process is about $23.7 million per year. Next topic is equipment cost. The equipment cost can be calculated by bare module method from the relationship of the bare module factor according to the following equation. CBM is the purchase and the installation equipment cost, CP is the purchase cost, and the other variable definition are shown below. In this regard, the calculation of equipment cost, the place of operation, and the cost in year used for calculation shall be taken. The variable definition and value are shown below. The equipment purchase and bare module cost is shown in the table below. So, the total purchase cost is about $3.2 million, and the total purchase and installation cost is about $12.8 million.
Economic analysis part. Start from the information. We use interest rate 7.585%, tax 20%, project life 20 years, and loan for 4 years. Next is the capital investment. It consists of fixed cost, land, and working capital. Due to amount of fixed capital and land is used to loan bank. List of fixed cost and working capital is followed by this table. This is the cash flow analysis of our project. At year 0, we buy land. The first year we use 60% for fixed cost investment, and residual 40% is used in the third years. We start to pay back loan at the end of year 3. From the cumulative cash flow graph, we can see the accumulation start to be positive in the year 7. In the year 3, the project value has the most negative with the year 3 start the production. Summary of cash flow analysis. The discount rate is from about X% of interest rate plus 5 from risk since our project is newly exhibition business. So the discount rate is equal to 13%. The present worth from year 20 to year 0 is $23 million, and the net present value is about $5 million. Interest rate of return is about 25% and use 8 years to get payback. The investment analysis might be changed in order that we use the most expensive price of raw material and the product use the cheapest price in last 6 months. Therefore, this analysis will get the lowest profit. The profit will be changed followed by the value of price in the market.
In conclusion, the reaction is assumed to be the one-step oxidation from propylene to acrylic acid in one reactor. The 99.6% biomass of acrylic acid production rate is 59,924 tons per year. Net present value is $4.9 million. On the other hand, the reaction on Advanced Pass program is powered by using kinetic data of reactions, activated energy, and K constant. The recommendation is that the data of catalyte should be input to Advanced Pass program for more accurate results. Therefore, the data of catalyte of one-step oxidation from propylene to acrylic acid should be researched and do the laboratory.